We are graphing general rational functions in different forms. And we have the example f of x equals x squared minus 5 divided by x squared plus 1. So the first thing that we want to do is we want to try to find our x-intercept. And we do that by taking the numerator and setting it equal to 0. And so our numerator is x squared minus 5 equals 0. So we can add 5 to both sides. And then we get x squared is equal to 5. And then we can take the square root. And then we get x is equal to plus or minus the square root of 5. So the square root of 5 is a little bit bigger than 2. So when we go to graph that, we'll just make sure that we have 1, 2. We're going to count by, we can count by 5s here as well. So 5, negative 5, 5, negative 5, and 5. So here's 2, and we'll go a little bit past. And here's 2, and we'll go a little bit past. The next thing that we want to do is we want to take a look at our vertical asymptote. And we do that by, we take our denominator and we set that equal to 0 and see what we get. So vertical asymptote in this case is x squared plus 1. We're going to set that equal to 0. So we can subtract 1. And we get x squared is equal to negative 1. And then we can take the square root of both sides. And then we get x is equal to plus or minus. We do know that the square root of 1 is 1, but we have that negative in there, so it ends up being plus or minus I, and so we have none for our vertical asymptote. Next thing we want to take a look at, and because our vertical asymptote is none right now, we know that our domain is also not going to be restricted. So that's going to go from negative infinity to positive infinity, and then we'll have open parentheses there. The next thing we can take a look at is our horizontal asymptote. And our horizontal asymptote we get by comparing the degrees here. And so we have x squared divided by x squared. And what that means is that we have m is equal to 2 and n is equal to 2. So m is equal to n. So when that happens, we take our lead coefficients of each and we make a fraction with them. So y equals 1 over 1. So y is equal to 1. And this tells us part of our range. I guess we'll have to wait and see. So y equals 1. We can sketch that. All right. And then we want to pick some points that we can sketch. So it's some x and y points. Let's pick 0. See what that does. So 0 gets the first two terms, the numerator and denominator, drop out. So we have negative 5 divided by 1. So that stays negative 5. And then let's try 1. So we substitute 1 in, 1 squared minus 4 minus 5 So 1 squared is 1 minus 5 is -4. And then 1 squared is 1 plus 2. So that ends up being -2. And -1 will also be -2. And then we can try 2. 2 squared is 4, minus 5 is -1. So we got 4 plus 1, so that becomes -1/5. So -1/5, and -2 is -1/5 as well. And then we already have the point that's a little bit past 2 drawn on there, so then we can sketch this pretty nicely. So we have 0, -5, 0, -5, which is down here. And then we have 1, -2. So there's 1, -2, and -1, -2. And we already have those. And I guess we can skip 2 for right now since we have one that's so close. So our graph is going to look like that. Now, when we're looking at our range, we don't start at -infinity. We actually start at -5. And we go all the way to 1. We don't touch 1, so 1 gets a parenthesis, and -5 is included, so that gets a bracket. Our x-intercept would be plus or minus the square root of 5. And then we can see that graph as well. And we have our asymptote at y equals 1. And we can see our y-intercept at 0, -5.